Okay, so for example, they give you magnesium plus hydrochloric acid, give you magnesium chloride hydrogen. So let's say magnesium is in excess. Okay, hydrochloric acid, they tell you is 1 mole per dm cube, 50 cm cube of hydrochloric acid. So this reaction, let's say you produce hydrogen gas, the rate of reaction graph, okay, the graph will be volume of gas against time. Okay, the graph will look something like this, will be like this. Okay, so now the question is, first, they say they change now, instead of 1 mole per dm cube, you use 2 mole per dm cube, 50 cm cube of HCl. Okay, the rest everything the same. So how will the new graph look like together with original graph? We are supposed to sketch together with original graph. Okay, so that's this kind of question. So this kind of question, first part you have to determine the gradient. The gradient, whether it's steeper, the same, or more gentle, it depends on what? It depends on the rate. Okay, and the rate depends on what? The 5 factors. So among the values given here, the 5 factors, of course, one of them is concentration. Correct? So when your concentration increase compared to original, here is 2, here is 1. Right? So the concentration increase. So when concentration increase, of course, the rate, the speed of reaction will become faster, will speed up. When your rate increase, of course, means the gradient will also become steeper. So for this question, your gradient must be steeper, initial gradient. So you have to have a steeper gradient. Okay, so that will determine your gradient. Second part of the graph, of course, is where the horizontal line should be. Should it be higher, same, or less? If higher, how much higher? Right? If lower, how much lower? So that part, the horizontal line position, depends on what? Actually depends on the mole of limiting reactant. Okay, why? Because the horizontal line is actually the total volume of gas that's produced at the end of the reaction. And total volume of gas, of course, is depending on the mole of the gas that's produced. In this case, the mole of hydrogen. And the mole of hydrogen is dependent on the mole of the limiting reactant that's been used up. Right, the standard mole calculation method. That's how we deduce. Right, so the horizontal line, whether it's more, less, or same, it depends actually on the mole of limiting reactant. Compared to original, whether it's same, more, or less. Okay, so for this question, you can see the one relevant to mole is the mole of HCl. And mole of HCl is concentration times volume from the values given here. That's how you find the mole. Okay, if you compare the question and the original values, the volume is the same, both 50 cm cube. Concentration, this one is 2, this one is 1. So that means the concentration is double. So if your concentration is double, volume the same, and multiply together, your mole will also be double. Right? So when your mole of the limiting reactant, which is hydrochloric acid, since magnesium is excess, is double, then of course your mole of the hydrogen gas will also be double compared to original. Okay, so when your mole of hydrogen double, of course your volume of hydrogen gas will also be double. So therefore, the horizontal line position will be double the original, which means here double, 2 times x, 2x. Okay, so after you know the horizontal line position, you know the gradient position, then you can just join. So this will be your graph for this part of the question. Okay, then now let's say they change a bit. They're not always concentration. Let's say now they change. Let's say now it's 1 mole per dm cube of HCl, but 100 cm cube. Okay, so same thing, right? You deduce the gradient and the horizontal lines position. So gradient, as usual, it depends, affected by the rate, and the rate affected by the 5 factors. Right? 5 factors here: concentration, pressure, particle size, temperature, catalyst. Here, only concentration applied, but concentration is the same as original, compared to original. So concentration is the same, and volume is not one of the 5 factors. Remember, what volume is none of the 5 factors that affect it. So since concentration is the same and volume is not a factor, of course means what? The rate will be the same. So if the rate is the same, of course means the gradient will be the same as original graph. So original graph is the blue color one. So the gradient for this also the same. The red color gradient the same. Right. Then horizontal line position, same thing again. Horizontal line depends on the mole of limiting return. And the limiting return in this case, again, HCl. So your mole of HCl is concentration times volume. For this part of the question, concentration is the same as original. Volume is double. So your volume, although doesn't affect rate, but volume can affect mole. So if your volume double times concentration the same, your mole will also be double compared to original. So again, if your mole double, your mole of hydrogen gas and your volume of hydrogen gas will also be double. Right? So that means this part of horizontal line will also be the double of original. So it's the same. So gradient, however, is the same as original. So you match, okay, you join. This will be your graph for part 2. Okay, so that is actually for this kind of question. Concentration is more troublesome because concentration can affect both the rate and the mole. Okay, other of the 5 factors that you learn only affect the rate. That means the gradient. It doesn't affect the mole. Okay, so this one that I give you is technically speaking actually the harder type.